Welcome back to GED Advanced Geometry. Take a slow breath and let's build this together one small step at a time. Today we learned the Pythagorean Theorem, one of the most useful tools on the whole GED math test. It works only for right triangles, and it lets us find a missing side whenever we know the other two. By the end of this session, a squared plus b squared equals c squared will feel like an old friend. First, let's name the parts, because the theorem depends on getting them right. A right triangle has one 90-degree angle marked with a small square. The two sides that form that right angle are called the legs, and we label them A and B. The third side, directly across from the right angle, is called the hypotenuse, and we label it C. The hypotenuse is always the longest side, and it is never one of the legs. Here's the theorem itself. In any right triangle, the square of leg A plus the square of leg B equals the square of the hypotenuse C. That is, a squared plus b squared equals c squared. The single most common mistake is to add the sides directly. You must square each side first, then add. And remember, this rule only works when the triangle has a right angle. Let's work a full example, slowly. A right triangle has legs of 6 and 8, and we want the hypotenuse. Step 1. Write the theorem. A squared plus b squared equals c squared. Step 2. Substitute the legs. 6 squared plus 8 squared equals c squared. Step 3. Square each one. 6 squared is 36, and 8 squared is 64. Step 4. Add them. 36 plus 64 is 100, so c squared is 100. Step 5. Take the square root. The square root of 100 is 10, so the hypotenuse is 10. What if the hypotenuse is known and a leg is missing? Then we subtract instead of add. Suppose the hypotenuse is 10 and one leg is 6, and we want the other leg. Start from a squared plus b squared equals c squared. Move the known leg to the other side. The missing leg squared equals c squared minus the known leg squared. That is 10 squared minus 6 squared, which is 100 minus 36, equals 64. Take the square root. The missing leg is 8. Some right triangles show up again and again on the GED, and memorizing them saves precious time. These are called Pythagorean triples. The most common are 3, 4, 5, 5, 12, 13, and 8, 15, 17. If you see two of these numbers as the legs, you can write down the third instantly without any calculation. Their multiples work too, like 6, 8, 10, which is just 3, 4, 5 doubled. The theorem also works in reverse to test whether a triangle is right. Take the two shorter sides, square each, and add them. If that sum equals the square of the longest side, the triangle is right. Check the sides 6, 8, and 10. 6 squared plus 8 squared is 36 plus 64, which is 100, and 10 squared is also 100. They match, so yes, it is a right triangle. Before we finish, let's dodge the three most common Pythagorean traps. First, do not add the side lengths directly. You must square them first. Second, do not forget the final square root. C squared is not the answer. C is. And third, only use the theorem on a right triangle. If there is no right angle, the rule does not apply. These small habits protect a lot of easy points. Excellent work today. You can now name the legs and hypotenuse, use a squared plus b squared equals c squared to find a missing side, recognize the common triples, and test whether a triangle is right. Your mastery check is the 10 practice questions for this session. For each one, write it out this way: given information, then formula, then substitution, then the answer with units. To read the full lesson notes and practice more GED geometry questions, visit the course page at www.bridgetoexam.com. I will see you in the next session where we apply this to real distances. Keep going. You are doing great.